Welcome to the Math Record. Today I'll be covering the CCML Algebra 2 Contest 1 2017-2018 Division A. Okay, let's start with number 1. If x plus 2y is equal to 3 and 4x plus 6y is equal to 8, determine x comma y. So we have x plus 2y is equal to 3, and we have 4x plus 6y is equal to 8. Well, usually I use the process of elimination, so I just multiply the first equation by -3 and then add them together. So that makes -3x plus that 4 is x. -3 times the 2, that's -6, cancel out the 6 here. Okay, so that just leaves equals 2. So -3 times 3 is -9. -9 plus 8 is -1. So I already got x is equal to -1. So plugging this back into the equation, right, that's our first coordinate, that's our x. That makes -1. So 3 minus -1 is just +1, so that's 4. And 4 divided by 2 to get y is just 2. So your answer is just -1, 2. It's basically just that simple and a really quick way to get the answer. Okay, number 2. Solve for q. 2 over q is equal to 4 divided by q plus 2. So what you could do is just multiply the numerator by the opposite denominator. So what it's do is that you're crossing it. So it's 2 times q plus 2, and 4 times q. So it's 2 times q, 2 plus times q plus 2 is equal to 4 times q. So it's just crisscross, and then you get it right. So this is 2q plus 4 is equal to 4q. So 4 is equal to 2q. So q is equal to 2. So your answer for number 2 is just 2. Basically just that simple. But usually for these questions too, if your answer 2, right, was and you put a denominator and it makes it undefined, like let's say your answer wasn't 2 but somehow 0. So if q is equal to 0, then you have 2 over 0, which is not possible. This is undefined. So always watch out for that one, because usually those are called extraneous solutions, because you can't have those solutions because it makes the function undefined. So look out for those. But since it's 2, it works out, because 2 over 2 is a possible number. It's not undefined. And 4 over 2 plus 2, which is 4, so 4 over 4 is not undefined also. Okay, number 3. Solve for y. So they say 2y plus 2 is less than 4y minus 2. So usually I like to keep the y positive, so I'm going to subtract the 2y here. So 4y minus 2y is 2y, and then add 2 to the other side. So if you have the variable on this side, you have to have the answers on the other side. So 2 minus -2 is just plus 2, so that's 4. Now divide by 2. Okay, so y has to be greater than or equal to 2. So this is a list of numbers. So you can have 2, but y also could be greater than 2, so like 3, 4, 5. So it goes up to infinity. So your answer is just rectangular bracket 2, and then infinity curvy bracket. Okay, so this is your answer. Okay, or you could just say y is greater than or equal to 2. I usually write it in this notation because it's usually it's something you learn in pre-calculus. So, but anyway, it's fine. But usually, this way is very good. Okay, number 4. Compute the product. 1 over 5 minus 1 times 1 over 6 minus 1, all the way up to 1 over 27 minus 1 and 1 over 8 minus 1. Okay, so what I see is that there's a pattern. There's 1 over 5, 1 over 6, and then I'm guessing it's 1 over 7, 1 over 8, 1 over 9, etc. So it just adds 1 to the denominator every single time. And then you subtract 1 from that kind of fraction, and then you keep multiplying. Okay, so how do we solve this? Well, if you have a calculator, there is something called product. I'm not sure for the TI-84, but if you have an Nspire, this is a type of calculator. You have this type of calculator. There's something under calculus for your calculator, and if you choose something with product, it would just actually do this for you if you put in the right variables. You can search out online how to do that, but it's pretty simple. It does the same thing as summations, but now with products. The actual way to do this with math is that we had to actually write it into a common fraction. So let's say -1, right? So you had to -1 for 1/5 is just 5/5, right? And then we're going to do 1/6, which is just -1, which is just 6/6, right? And then multiply by etc. Let's just do one more. 1/7 minus 1, right? So 7/7. And then etc, 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 you know? Etc. Until like 1/27, right? 1/27 minus 1, which is just 27/27. And then 1/28 minus 28/28. Okay, so why do I do that? Well, if you kind of simplify it, right? So 1 minus 5, since it's common factor, you can subtract it. You get -4 or 5. Okay, so that's your first number. Okay, let's kind of split this up so then we see we're working on this portion. So 1/6 minus 6/6 is just the same thing as -5/6. Now 1/7 minus 7/7, which is -6/7. And then etc. until you go up to like these numbers, right? So if you kind of look at it, since you're multiplying, right, you could just cancel out numbers from the top and bottom. Look at this. We cancel out the 5 here and here. We cancel out the 6 here and here. Now, if you have like 1/8 minus 1, right, which follows right here, then technically it's just 1/8 minus 8/8, which is just like -7/8. You see how it keeps crossing? So I'll use a different color so it looks more obvious. So we have cancel out the 5 here, and then let's use blue, and then we could cancel out the 6 here, right? You see how it works? So it looks like every single like number, whatever is the denominator on that number, is gotta be a numerator on the next number. So if we kind of keep crossing them out, and since they're products, it kind of works like that, then basically all we need to do is that we need to find what is the value that is left over. So if we kind of see this pattern, right, the numerator that's only left over is the -4. And you kind of think about it, the only thing left over on the denominator should be this, the 28, right? Because if you keep canceling this out, this -26, right, over 27, and this is -27 over 28, that 27 minus that 28, right? And then that 26 is going to be canceled out by something over here if you have more, right? Because it keeps on going that pattern, so anything in between kind of gets cancels out. So if you think about it, we just have that -4 over this -28. Okay, so 4 over on the numerator and 28 on the bottom is just 1/7, right? But before we say that is the answer, we see that these are negatives, right? So it's -4/5, -5/6, -6/7. So it's either plus 1/7 or -1/7. So you have to find out how many there are. So an easy way to do it without actually doing a bunch of math is that if you have, let's say, 2 terms, right? We subtract them together. Let's say we only have 5 and 6. 6 minus 5 is 1. That there's a difference of 1, but there's 2 numbers, right? There's 1/5 minus 1 and 1/6 minus 1, and you're multiplying those together. So there's 2 numbers, but there's a difference of 1. Let's do something else. Let's say we add the 1/7. So 7 minus 5 is 2. There's 2, but there's 3 numbers, right? So if you kind of think about it, every single time we have a number, if we subtract these numbers, we have 1 more than actually that subtraction, right? So we have 6 minus 1. That's a difference of 1, but we actually had 2 numbers, right? So it's 1, 2. And then if we have 7 minus 5, that's a difference of 2 numbers, right? But we actually have 3 numbers. You see how there's always 1 more than like the next one? Let's say we have 1/8 minus 1. I'm not gonna draw it because I don't have room. So 8 minus 3 is 8 minus 5 is 3, right? But we have 4 numbers, 5, 6, 7, and 8. You see how there's always 1 more number than the difference? So basically what we need to know is that there's 28 is the max. So 28 minus 5 is 23. So that means adding 1 to it, that's 24. That means we have 24 numbers. since that means there's 24 numbers, which is even, that means there's even amount of multiplying by -1. That means that should be, all the -1 should cancel out to be a positive. So this is the right answer. So the answer for number 4 is just 1/7. It's basically just that simple. It's mostly just about logic. So if you ever see any patterns with like multiplying and adding, there's usually a pattern where you can start canceling out numbers, and it's usually just the first number and the last number. But sometimes it might be a little different than that. Okay, number 5. To the right are 3 non-overlapping regular hexagons that meet at the vertex. Okay, like this. Their centers are connected to form the boundaries of a shaded region. What fraction of the diagram is shaded? Okay, let me draw a hexagon. Sorry if it looks bad. I'm not the greatest artist. But basically, what we're going to do is that we're only going to focus on one hexagon. Because if you kind of think about it, if you kind of cut the hexagons into third, right, at the sides, basically, it's all going to look the same, right? Each hexagon with that shaded region all looks the same. So the fraction, the proportion is going to stay the same for all 3. So even if you multiply so if you add them all together, right, you have 3 times the shaded region, but you also have 3 times the hexagon. So the 3 divided by 3 is just 0. So the only thing we have to do is that we need to look for the proportion for one of these hexagons, and then basically it's going to be the same thing as the entire shape. So that's all we need to do. Okay, so we just need to find that area. So let's just vertex to here, and then all the way to here, and that makes a right angle. This is basically the same picture as that shaded region. I'm just rotating it down so it looks easier to see. Okay, so what we're gonna do is that we're just gonna look here, right? So this is really easy. We don't even have to do any calculations. So if you think about it, right, we have this shape. Now we could just make another one right here, right? And you make another one right here. That's a right angle. So it looks like these. So it makes this, 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 and this, right? That's all we have to do. So our initial was these 2, right? So technically, all we had to do was just count the amount of triangles we can make there. So we can make one more here, right? I'm just redrawing it. Then make a right to the side, then to the side, and right here, right? So basically, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Right? We have 12, but only 2 of them were shaded, right? It's only this region. So 2 out of the 12 is 1/6. And since I said that the one of the hexagons is the same proportion as the entire thing, because you have 3 times as many shaded region, but you also have 3 times as many hexagons, so that 3 divided by that 3 is the same thing as 1. So the answer is just 1/6. It's basically just that simple. You don't even have to do any calculations. All you have to do is that you could just think about it and look at the picture and then start like logically see patterns and then just put them together. Okay, so 5 is 1/6. How many order triples of positive prime integers x, y, and z satisfy the relation x squared plus y squared is equal to z squared? Okay, so x squared plus y squared is equal to z squared. And all x, y, and z are primes. Okay, so the thing about this is that if you kind of, instead of think about numbers, we're going to think about the properties. So usually when I think about primes, I'm thinking about like numbers for even and odds, usually. So the only combinations, let's focus on x and y. The only combinations for 2 numbers is either odd, like 2 odds, right? And then even, or even, odd. You might say there's odd, even, but that's basically just the same thing as even, odd. It doesn't matter if you switch the odd and even. It's gonna be, each of them is gonna be squared and you add them together. So it doesn't matter. So you don't have to check those conditions. Okay? So immediately we could cross out a lot of possibilities. They say there are x, y, and z are are primes, right? The only even prime is 2. So if we check 2 and we see that it's wrong, it's not going to work. So how do we know that 2 is not going to work? Well, basically, if you kind of think about it, you have x squared plus y squared is equal to z squared. Doesn't this formula look really familiar? Well, it's the Pythagorean theorem, right? The Pythagorean theorem, the smallest Pythagorean triple is 3, 4, 5. See, like 3 squared plus 4 squared is 9 plus 16 is 25. 5 squared is 25, so this is true. That's the smallest Pythagorean theorem, which is with primes. So which is usually what everyone knows from like math. So if you want to use a prime with 2 for the Pythagorean theorem, it does not exist because this is the smallest. So we could immediately cross out any even like prime. This is not going to make sense at all. So technically, this is wrong because there's no even primes in this because 2 does not work. So also this does not work. Okay? So the only possibility we had to work with is odd, odd. Because even and even, you can't have it. That means both of them are 2, which does not work. And if it's even odd, it's just even, 2 and some kind of odd. But you already said even doesn't work, so you can't have that. So the only possibility is left is odd, odd. So if you kind of think about it, if it's odd squared, right? Odd squared is just the same thing as an odd, right? And then an odd squared is just another odd. Now you add those odd together, that gets even. So now you have even is equal to z squared, right? So you take square root of even if it's going to be a decimal, it's going to be even, right? So that contradicts what we have said, which is x, y, and z are all primes, right? And we already said that the primes cannot be 2, so it cannot be even, because 2 is the only even. So this does not make sense, because that is not going to be a prime. So this possibility is also cancelled out. So since all our possibility cancels out, that means none of them work. So the answer is 0. Because how many order pairs can satisfy the relationship? Well, none of them can satisfy it, because there's no possibilities where it can actually satisfy. And that's basically how you can think about it. So usually this is more of a theoretical question. So usually instead of the easier way to do this is that if you know your Pythagorean triples, you could kind of see a pattern. So if you know your Pythagorean triples is 3, 4, 5, instead of thinking of odd, even, even, odd, odd, and even, you could just look for patterns for Pythagorean triples. So you don't know that way. So 3, 4, 5, right? The next Pythagorean triple is 5, 12, 13. The next one is 7, 40, 41, I believe. Actually, no. 7, 24, 25. I'm sorry about that. And we have 8, 15, 17. If you kind of look at it, we have if we kind of look at this list and you kind of make some generalizations, we could say 4 is not prime, so this does not work. 12 is not prime, does not work. 24 is not prime, that does not work. 8 is not prime, does not work. If you kind of see all these patterns, there's always some kind of odd plus an even. So since there's always an even, right? There's always an even, but it's higher than 2. So if it's an even and it's higher than 2, that means it's not prime. So it does not work. So if you kind of think about it, you can logically just say the answer is 0. Because, like, if you kind of see the pattern, there is always this even, and since they're not primes, then basically it does not follow any of this rules. So you could just say it's wrong. Okay, question 7. A scaling triangle has the longest side length of 40, another side length of 20, and a third side length of x. If x is an integer, give the sum of all possible values of x. Okay, since the largest side length is 40, right? We have that means the two smallest is 20 and x. So we have x, 20, and 40. Usually that's how I write it. I write the smallest on the left and the largest on the right, which is 40. So the inequality for triangles is that the two smallest, which is a and b, has to be greater than the largest, which I'll say is c. Right? So this has to be true. So that means x plus 20 has to be greater than 40. So 40 minus 20, that means x is greater than 20. So basically, the lower bound for the equation is 20. So x could only is for starting at 20, but it cannot include 20, because if it includes 20, that's 40 is equal to 40, which is not, so that triangle does not exist. It has to be greater than 40. So it has to be starting at like 21, because they say integers. Okay? Now, what's the upper bound? Well, the upper bound is 40. But you can't include 40. So how do I know it's 40? Well, it's at at 7, it says in the first line that the longest side length is 40. So it cannot be longer than 40, because then the longest side length will not be 40. It also cannot be 40, because they said that the longest side, it has a longest side length of 40. That means that side length is the longest. So you cannot have another 40, because then you have two of the longest side length. So basically, we just need to find all the sum of the integers between 20 and 40, which is 21, 22, 23, 24, etc., all the way up to 39. So that takes too much work. So usually in the CCML, you like to save time. So instead of doing all that, you're gonna you just gotta know formulas, which is really simple. So usually there's only a set amount of formulas you need to know, and this is one of them. So this is the sum of the arithmetic sequence formula, which is basically, you probably learned this in class 2, like just in any math class. Generally, they have the sequence, which is the number of terms divided by 2, and then multiply in parentheses. It's going to be the first term plus the last term. Okay, so the first term plus the last term multiplied by the number of terms between them, and then divide by 2. So how do we know how many number of terms are between 20 and 40? Well, instead of like integers between 20 and 40. Well, instead of using this big number, I like to use smaller numbers, so then I can scale it up to think about it. So let's use 20 and like 21, right? How many integers can we use from 20 to 21? Well, the only integers between 20 and 21 is just 20 and 21, right? But you cannot use 20 and you can't use 21. So that means there's 0. But what's the difference? 21 minus 20 is 1. But we have a difference of 0. So the idea that this happens, you have a difference of 1, but there's actually 0 solutions. That means whatever I have for the difference, I just got a minus 1, right? So let's try something else. Since that's only one example, let's try something else. Let's increase that to 22. Yeah, 22 minus 20 is 2. What's the integers between 20 and 22? 20, 21, and 22. But we can only use one of them. We can only use one. We can't use 20 or 22 because these are curvy brackets. So it does not include 20 and 22. So we also see the same property. We have a difference of 2, but the difference of 2 minus 1, right? You got a minus 1 equals 1. So we only have one term, right? So now if we kind of apply the same thing to 20 to 40, so that was just an intuitive way to do it. If you kind of know how to do it, you don't have to follow that step, but usually that's how I do it to remember. So we have 40 minus 20 is 20. But that was the difference. To get the number of terms, we got minus 1, right? So we got minus 1 is equal to 19. So we have 19 terms. Or you could just count out like 21, 22, 23, all the way up to 39. You just count how many numbers are there. Which same thing, it's just 19 terms. The 19 terms divide by 2. But that was just a faster way when I was using the 2021 and 2022 just to test. So the first number is not 20, but 21, because it does not include 20. It has to be an integer. So the next integer is 21. And the highest integer is 39, because you can't have a 40. Okay, sorry, I had to add those two. So 21 plus 39 is 60, right? But 60, since there's an I, which is 19, and the even is 60, and we had to divide by 2, which is even, we just had to divide 60 by 2. Sorry about that. So 60 divided by 2 is 30. So we just have 30, cancel out this. So 30 times 19. And that's the way I was assigned. So, what is this? 30 times 19. Well, we could just have that as 3 times 10. So 19 times 3 is 38, 57. Okay, so 57 multiplied back to 10. So your answer is 570. Basically just that simple. Okay. So far, the questions 1 through 7 is pretty simple. Except for number 6, which might be a little hard, but if you see patterns, it's pretty simple. Also, number 4. 4 and 6 are basically just patterns. Okay. Let's go on to the next question. Number 8. The measure of the interior angle of a regular N-Gon is 160 degrees. Determine the value of n. Well, this is also another formula you should know. For geometry, there's basically, if you want to score high for the CCML, you just gotta memorize formulas. The reason is not because it's like easier to do it, or it kind of is, but basically is that you want to save time. For contests like this, you want to save time. What you want to do is you memorize formulas and you basically just know it. And you basically just do it. So the measure of an interior angle of an N-Gon is 160 degrees. So what's the interior angle of any N-Gon? So we have an N-Gon, right? The interior angle of a N-Gon with side length n, right? As n is the number of sides. So if n is equal to 5, that's 5-gon, which is basically is a pentagon. So the idea is that it's 180 times n minus 2 divided by n. That's the formula. So how do you remember? Well, basically, the first part is just the sum of all the interior angles. So, right, let's say we have 4, right? 4-gon is basically just going to be a square or a rectangle. It doesn't matter. So 4 minus 2 is 2. 2 times 180 is 360. Which is true, right? Because if we have a square, that's 4 right triangles, which is a right triangle is 90. So 90 times 4 is 360. So that's true. Now n is divided by 4. So we have 4 right triangles. Divided by, that's equals 90. 360 divided by 4 is 90. Right? So that's true. So we know this equation has to be true, and that's how I memorize it. So the top is the number of is the sum of all the interior angles, right? These angles right here, basically. It doesn't have to be right triangles. I'm just showing you a shape, so which are the interior angles, basically. So this is just an example. So another example would be like, let's say we have a hexagon. The interior angles would be this one, this one, this one, this one, this one, and this one, right? So there's 6 of them, and that's why you divide by n. Because if you have 6 side lengths, you also have 6 angles. And that's the formula. You should just memorize it. So this formula is equal to 180 because 160 because that's what they said. So let's kind of just distribute that out. So 180 minus n, 180 n. 180 minus multiplied by negative 2 is negative 360. And 160 times n, 160 n. So subtract 180 minus 160 is 20n. And then move the 360 to the other side. And 360 divided by 20, so it's 36 divided by 2, which is basically 18. 10 divided by 10 is 0. So this is true. So our side length is basically just 18. Basically just that easy. So if you know your formulas, you basically just save a lot of time. Okay, number 19. Quadrilateral META has diagonals that meet at L, creating 4 non-overlapping triangles. The area of 3 of those triangles are shown in the diagram to the right. What is the area of triangle ELT? Which is basically just the last triangle that they didn't give us. The area of the last triangle they didn't give us. Right? So yeah, something like this. Line right here, right? And they said this area is 6, this area is 4, and this area is 1. And we're looking for this area. Okay. So basically, it's really easy. All you have to do is that you have to understand how triangles get their area. So a lot of geometry is that you just got to understand relationships and formulas. So we're going to have to look for this side length right here. Okay, so we're going to focus on this triangle, right? So basically, you're going to see a 4 and you're going to see a 6. If you kind of think about it, this triangle has the same height, right? It has the same height. This is not the height, but it doesn't matter. The point is that if you have like, let's just make like something perpendicular, right? Perpendicular, and you find the area. Well, basically, since they're at the same triangle, right? At 6, sorry, this one side is 4, and 6. Kind of just rotate it down. Basically, this is gonna be at the same height. The idea is that this is called which I refer to as a split triangle. If the area is 46, that means the side lengths also have to be 46. Because it's just base times height is equal to area, right? So if the area are in proportion and the height is the same, that means the side length, right? So we have side length times height is equal to the area. So if the area is in proportion and the height stays the same, that means the side length are the ones that are in proportion. So it's just some kind of logic in here, right? So the ratio of this to this is that instead of doing all the calculations, just say this is 4x is 6x. Okay? So applying this, that means this is 4x and this is 6x. We don't know what the side length is, but we don't need to find it. It's not important. Okay? So using this idea, we'll just use it for this triangle now. Okay? So we have this triangle. I draw it down. This is area 1, and we have this area, which is area A. and we said this side length ratio was 6x, and this side length was 4x, right? Because we're doing this triangle right here. And then basically, since this is 4x to 6x, how do you scale up 4x to 6x? Well, you just multiply this thing by 1.5, right? So 4 times 1.5 is 6. Well, basically, then you just had to multiply 1 times 1.5, which is just 1.5, right? So your answer is just 1.5. It's basically just that simple. You just need to understand how triangles work, and you see the relationship, and it always works. So based on the idea, the general idea is just like if you have like area of, let's say this side length is 2 times more than this side length, right? Basically, that means this area is 2 times more than this area, which is basically just the general idea of how it works. So if it's like 3 times the side length, then it's going to have 3 times the area. And that's the general idea for number 9, which is pretty simple. Number 10. In a triangle with side lengths 44, 240, and 244, compute the length of the median to the longest side. Okay, there's 2 methods that you could use. The first is really well known, which is basically the law of cosine. So, as I said, geometry is a lot of more memorizing of formulas, which is basically the law of cosine and the law of sine. Just know your trigs, because geometry has to do with anything related to anything with shapes, which also include trig ideas. So for a triangle with side length 44, 240, and 244, compute the length of a median. A median means that to the longest side length. So we have 44. I don't care where the 44 is. The median is basically just a line right here, and then you split this up to the same length, right? So the distance from here to here is the same as the distance from here to here. Okay, so these have to be the same length. So since this is 244, and this entire length is 244, and you split up into equal, that means this is 122, and this is 122. Okay. So how do we use the law of cosine here? Well, we're just going to use this angle, or we use this angle. It doesn't matter. The point is that you're going to use one of these angles. So if you use this angle, we're going to think about it in 2 triangles. We're going to think about the law of cosine here for this triangle, right? In relationship to this side length. And then we're going to think about this entire triangle, right? So, or actually, you're going to think about the larger triangle, and then you're going to think about the smaller triangle. Okay? So the idea is, how it works is, let's kind of erase this so then we get a little bit more space. So, oops, sorry about that. We'll have a smaller version. That's 44. That is 240. And each of them is 112. Okay. So the point is, how you do this is that let's do the largest triangle in respect to this angle, which is basically, we're gonna call this angle theta. Okay. So the point is, the law of cosine is that the opposite side length of that angle, which is this side length, because this is our angle, so the opposite side length is this. The opposite side length is equal to the 2 side lengths, the sum of the squares of those side lengths, okay, minus 2ab cosine of theta of this angle, which is theta. Take the cosine of that angle. So this is the law of cosine formula, which you just need to know. So our c squared is 240. The 240 squared is equal to a squared, which is this side length. We put it in half. This is also 112. So our side length was 244. So it's just 112 plus 112 because it was just bisected. So it's 244 squared plus the 44 squared minus the 44 times the 244. Sorry, I'm running out of space. Times, sorry, it's 2 times the 44 times the 244 times cosine of theta. Okay. We don't know what cosine of theta is because we don't know what theta is. But that's the point is that we don't need to know it. So if you kind of already use your calculator to do the calculations, so we could like already simplify. So 240 squared minus 244 squared minus 44 squared. And then you divide by 2, divide by negative 2, divided by 44, and divided by 244, right? So you already get the, oh, sorry, this is 122. Sorry about that. But the calculation is still the same thing. I was using different numbers anyways. So the point is, when we kind of rearrange everything, so we just isolate the cosine of theta, we get that, see, 244 squared minus 244 squared minus 44 squared, then divide by that negative 2, divide by 44, divide by 244 is equal to 11 over 61. Since this is contest 1, you basically use your calculator for this, so you don't make any math mistakes. So 11 over 61. Okay. So we already get 11 over 61. So I'm going to erase all my work just for space. So we already get cosine of theta, which is 11 over 61. 11 over 61. Okay. So now we're going to, since we did the smaller, larger triangle, right? Now we're going to do the smaller triangle, which is right here. Because then we could take this side length right here, right? Because that's what we want to look for. We want to find, for question 10, we want to compute the length of the median. The median is this line, basically. So we want to find that length of that line. So you kind of think about it. We have this triangle now, which is 44, the 122. And then let's call this side length x, right? And this is still theta, which is just this triangle. So that's why I said, like, you could use either this angle or this angle. It doesn't matter. It's still going to basically give you the same numbers. Okay. So using this idea, which this is theta. Oops, let me draw this a little better. Okay. Somewhat better. Okay, so using the law of cosine again, which is opposite angle, which is x squared. So x squared is equal to 44 squared plus 122 squared minus 2 AB, which is 44, and 122, times cosine of theta. We already got cosine of theta from our previous law of cosine use, which is 11 over 61. So plugging this all in your calculator. So 44 squared plus 122 squared, right? Minus 2 times 44 times 122 times cosine theta, which is 11 over 61. You get 1,000. Oh wait, you get 14,884, right? As equal to your x squared. Now you just want x, so you just square root it, and you get 122. Right? So your answer for x, which is the medium of your length, which is what you were looking for in the question, is just 122. So your answer is just 122. And that's the first way to do it, using law of cosines. Another way that is usually how I would do it, it's just that because using law of cosine, you have to do it 2 times, which kind of wastes a lot of time. So how I do it is that there's something called Stewart's theorem. Okay. You can search it up. It's basically just a really, really long formula, but if you do a bunch of times, you kind of remember it. It's really simple. So the idea is that we have something like this. And let's call this A, we call this B, we call this X, and we call this M and N, right? And this entire side length is M plus N, right? Well, basically from this triangle, we could get the idea. Actually, I kind of drew this a little bit too big. Just remember that's M plus N. Okay? So the idea is that the formula is A squared times N plus B squared times N. It's the same thing as M plus N, right? This entire side length times X squared plus M times M times N times M plus N. This is a true formula. Both of A squared times N plus, B squared times M is equal to M plus N times X squared plus M times N times M plus N. This formula has to be true. So it's easy to memorize. Just square one side and then multiply by the opposite, so the n, and then plus b squared and then multiply by the opposite n. And then you basically just have to memorize this portion. Okay, but if you do a bunch of times, it's just basically like ingrained into your memory. It's really easy. So using that formula works for anything. It doesn't even have to like make a median. It just basically has to be a side length that separates two side lengths m and n. So using that idea, we have 122, right? And that was 122. This is 44, and this is 240, right? So our idea is 44 squared, times 122. Let me write this a little smaller, actually. 122 plus 240 squared times 122 is equal to, we'll have x, which is what we want to look for, which is 122 plus 122, which is 244, the entire side length, times x squared, plus the 122 times the other side length, which is also 122, times the entire side length, which is 244. So you just have to follow the variables and you get it right. 244. Okay, so just do the math on this, which is really simple. So 44 squared times 122 plus 240 squared times 122. Okay, and then basically you have this subtracted by all of this. And then you just divide by the 244 and then square root it. And then you basically get the area. So this number subtracted by 122 times 122 times 244, right? And then you divide by 244, square root. And you get the same answer as before, 122. So that is usually the way I do it. It's just one quick method. But both ways are valid. It's just that one log cosine takes longer. Okay, number 11. A triangle with vertices -5, 1, 0, 5, and 1, 1 is dilated with respect to P to create a new triangle with corresponding vertices of -8, 2, 2, 10, and 4, 2. Determine the coordinates of P. Okay, so this says dilations. So basically, we have something like this. So it's not going to be drawn to scale. So -5, 1, something right here. And then 0, 5, so something right here. And then 1, 1, so something right here. Okay, so I have this triangle. And then we have something like -8, 2, so something right here. 2, 10. Okay, so that's why I said it's not drawn to scale, because I put 5 all the way up here, but this is 10. Sorry about that. And then we put 4, 2. So something right here. Okay, so it's supposed to be way up to the top. That's why I said it's not drawn to scale. Just draw bad at drawing. So basically it looks like this. So it has corresponding points. So this is corresponding with this corresponds with this corresponds with this, right? So basically what you have to understand is that the where you're gonna dilate it from is basically the intersection of those lines. So basically you only have to choose 2 points. So usually I kind of choose the border points. So I choose something right here, and I choose something right, which is this one, right? So where those line intersects, that is where is the point of dilation. Okay. I have bad handwriting, but basically you just kind of have to look for those, which is really simple. So we already got the points. They said corresponding points, so we really didn't have to draw a picture. So we just had to find the equation through -5, 1, and -8, 2. So 2 minus 1 is 1, -8. So change your y or change your x to get your slope. So y is equal to change your y, change your x. So 2 minus 1 is 1. -8 minus -5 is just +5, so that's -3. So that's -1 over 3x. Okay, and it has to go through 5 and 1. So plug in -5, 1. So plug in -5 here. That's 5 over 3. But we need 1. 1 is just 3 over 3. So this is just -2 over 3. Right? Which also satisfies this one because it's -8. Plug in -8. That's 8 over 3. Because negative times negative is positive. So 8 over 3 minus 2 over 3 is 6 over 3, which is equal to 2. So this equation is true, which goes through -5, 1, and -8, 2. Next equation, which goes through 1, 1, and 4, 2. So 2 minus 1 is 2. 2 minus 1 is 1. And 4 minus 1 is 3. So the slope is 1/3. Change your y or change your x, you know? Basically, really quick math, so you save time. So it goes through 1, 1, so you put in 1 here, and you need to get 1 as output, so 1 is just 3 over 3, so you only have 1 over 3, so you need to add a 2 over 3. So you could check, so you put a 4 in here, so 4 over 3. 4 plus 2 is 6, 6 divided by 3 is 2, which is true. So now you just have to set them both equal to each other. So you have negative 1/3, x plus, minus 2 over 3 is equal to 1/3 x plus 2 over 3. Okay. Let's kind of move this up because I'm running out of space. Okay. Now just I usually like to have the whatever the variable, the constant is positive, so I'm just gonna add 1/3 to both sides, so this gets 2/3 x, and then subtract 2 over 3 from both sides, so that's 4 over 3. So x has to be 2. Okay. Now plugging it back into one of these equations, it doesn't matter. It's gonna give you the same thing anyways. So I'll put in here, so 2 over 3 plus 2 over 3 plus 2 over 3, that's 4 over 3. Okay. So for number 11, the coordinates of dilation, it's basically just gonna be at 2. Oh, sorry, I did the calculation wrong. That's supposed to be negative 2. Sorry about that. So this is negative 2. This is 2/3 and negative 4 over 3, so that's negative 2. Sorry about that. So you plug in negative 2 into one of the equations, so negative 2 over 3 plus 2 over 3, that's just 0. So the point of dilation is negative 2 over 0. Negative 2, 0. I'm sorry about that. And that's for number 11. Okay. And number 12. Determine the distance between the lines given by y equals square root 3 and y equals square root 3 plus 4. Okay, when they usually ask for the distance between two lines, they're parallel. They have to be. Because if you think about it, if they're not parallel, that means they're intersecting. So if they intersect, that means the distance is always changing. That means the smallest distance is 0, because they intersect. That's why they always have to be parallel. So it looks like this. Okay. So let's actually just draw like actually a good picture. So this is y equals square root 3 over x, square root 3 times x, and this is y equals square root 3 over x plus 4. Okay. So this is at 4. Okay. But the point is, you're just gonna put a line through it. So the smallest distance is usually a perpendicular line through both lines. It's gotta be perpendicular since they're parallel, right? So a perpendicular line to this line would be the same thing as perpendicular to this. And then basically, we just need to find the distance between there. And that would be the smallest. Okay, because we don't want to find a distance like this, because that's like a hypotenuse. If you draw a triangle that's perpendicular right here, right? Wouldn't this side length be smaller than this? So you just want to find the perpendicular. And basically, it's just that simple. And it's really easy. So what you have to do is perpendicular side length means a perpendicular line would be like you have a perpendicular slope, right? Perpendicular slope is just opposite and reciprocal. So opposite of 3, square root 3 is negative square root 3, and reciprocal of square root 3 is just 1 over negative square root 3, right? So opposite and reciprocal. And that's what we get. So it's negative 1 over square root 3. And that's x. Okay. You don't have to look for b. It doesn't matter. Any equation with negative 1 over square root 3 to these equations to y equals square root 3, well, and plus any number, it's gonna be perpendicular. The slopes just have to be perpendicular. That's all it has to be. So basically, you just have to find the intersections between this line, and each of those lines. So let's work with y is equal to square root 3x's first. This is pretty obvious. The intersection is 0, 0, right? Because there's no b, so it's just gonna look like this, right? So you have something like this, and then you have a perpendicular line to it. So it's just gonna meet at the origin. Basically, just that simple. So the first one is 0, 0, and that's why I started with the first one. This is easy. Now we have negative. Now we have in the other equation, which is the square root 3 plus 4. Okay, So y equals square root 3 plus 4. Okay, so we have to have negative 1 over square root 3. X is equal to square root 3x plus 4. Okay, so we're going to add 1 over square root 3 to both sides. So if we would like to do the math, we'll just multiply square root 3 on top and bottom. So this would be the same thing as saying 3 over square root 3, right? Square root 3 is just 3 over square root 3, which is basically plus 1 over square root 3. So it's just 4 over square root 3, right? So this side length is 4 over square root 3x. Move 4 to the other side, so that gets negative 4. So you kind of see it. X has to be multiplied by negative square root 3, right? So then you cancel out the square root 3 on the bottom, and then you have that negative to make that negative 4. So your x is negative square root 3. Okay. So erase all that, so I need a little bit more space. So x is negative square root 3. Now we just need to look for the y. So plug in there square root 3 to one of the equations. It doesn't matter. So let's plug into this one. So square root 3 times negative square root 3 is just negative 3, right? Negative 3 plus 4 is 1, which also makes sense. Which also makes sense here, right? Because like negative 1 over square root 3 times square root 3 cancels out. The negative times negative is positive. So we have these two lengths. And it kind of looks like this. So we have 0 here, and then we made a line go through that. So this would be 0, 0. This would be negative 3, 1. And now since now we just need to find the distance between 2 points, and that will give us the distance of that line, right? Which is basically just that simple. So the distance between 2 points is just subtract the y coordinates, subtract the x coordinates, square those values, and then add them together, and then square root it. So negative square root 3 minus 1 minus 0 is negative square root 3. 1 minus 0 is 1, and then you square both of them, right? So negative square root 3 squared is just 3. 1 squared is just 1. And then you add those values together, so that's 4. And then you take the square root to get the distance, which is equal to 2. So the answer for number 12 is 2. Okay? Basically just that simple. Number 13. A mixture of vinegar and water has an initial volume of 200 milliliters and a concentration of 40 vinegar by volume. How many milliliters of pure vinegar needs to be mixed into a sample so that the resulting concentration would be 45.45 repeating percent? Okay, so what we like to do is that we look for proportions. So we have a mixture of vinegar and water has an initial volume of 200. So we have 200 as our initial volume. And then we're going to look for what's the proportion of 200 is vinegar. So 40% is vinegar. So 40% times 200, so 0.4 times 200. 0.4 is the same thing as 2 over 5 times 200. So that's 40. So 40 times 2 is 80. Okay. So we have 80 milliliters of vinegar, right? So this is our initial. Now we want to increase it. So we're how many milliliters of pure vinegar? So it's 100% vinegar. So if we add 100% vinegar, like we have 50 milliliters of percent pure vinegar, we have 50% vinegar, right? So we just add to that 80, and then our total will just raise by the same amount, right? So it's basically this. So x is what we're gonna say is gonna stand for it. Now it's equal to now that is equal to the proportion that's at the ending, which they already gave us, which is the resulting concentration would be 45.45% repeating, right? So that's the same thing as 45. 45 repeating is just 45 over 99. So you could simplify that to divide 9 from the top and bottom. So that is 5 over 11. Okay. So 45 and 5 over 11. We could get this into improper fraction. So 45 times 11 plus 5. That's 500. So that's 500 over 11. Okay. So 500 over 11. And you basically just cross multiply and start multiply. So 11 times x is 11x. 80 times 11 is just 880. And then 500 times x is 500x. And then 500 times 200 is just 10. 5 times 2 is 10, so then you have 4 more zeros. So 1, 2, 3, 4. Okay, so you can just do the math here, which is basically just going to be, oops, sorry about that. This is 45.45. That's a percent, so I need to divide by 100. So I need to divide by 100, so just add 2 more zeros, basically. So all you have to, so if you had 2 zeros on top, 2 zeros on the bottom, you could just write 5 over 11. Okay. So sorry about that. So 11 times x, 11x, that's 880. 5x, 5 times, and then 5 times 200 is 1000. Okay. So subtract 5x from both sides, so that's 6x. 1000 minus 880 is 120, so x is equal to 20. So how many milliliters of pure vinegar you need to add? You need to add 20 milliliters if you want to add your new units. So that's your answer for number 13. Okay, question 14. A triangle has vertices at 1, 1, 3, 2, and 2, 4. Determine the distance between the triangle's centroid and circumcenter. Okay, so there's vocabulary here. So there's a centroid and circumcenter. Let's learn about centroids first. Centroid would be like if you draw a line right here, and that makes a median, right? And then you draw another line right here, that's a median. And because these two side lengths are the same, these two side lengths are the same. These two are not the same. It doesn't have to be the same, but it could. And then you put a line here, and these two are the same. I just have really bad drawing, but it generally these this side length is the same as this side length. This side length is the same as this side length. This side length is the same as this side length. Basically, that's what it's saying. And all of them intersect at one point, and that is called the centroid. Okay, so that's the thing you have to understand. A special property about the centroid is that the distance from this line, from this point to this point, and from that point to this point, this is ratio 2 to 1. It's the same thing from 2 to 1 and 2 to 1. And that we're gonna use this concept to get that point, and then we can find the distance. The circumcenter of a triangle is where a circumcenter is that a circumradius is that basically you draw a circle around the triangle, right? And then you're gonna find this point. This point is gonna be called the circumcenter. And then you draw a line through all these vertices, right? Because it's a circle that passes through all these, this entire triangle, so it passes through only these vertices. And all these side lengths are the same length, and that's what it's saying. There's a point inside the triangle that the distance from that point to the vertices are all the same length, and that's basically what it is. That's the circumcenter. So the easy way to find the circumcenter is basically take the angle bisector of, the perpendicular bisector of 2 lines. So it doesn't matter 2 lines. You have 3 lines, just choose 2 of them. So you take this one, and you take this one, right? It's perpendicular to this side length, and this one's perpendicular to this side length. Wherever it intersects, that is where the circumcenter is. So why is that true? Well, basically, if you have a perpendicular bisector, right? This is the same length as this. That means if you choose this as a height, let's say the point was like right here, then this has the same height and the same length. So these 2 lengths are going to be the same. So from the distance from this vertice to this vertice is the same, right? And if you take the perpendicular bisector right here, that means this side length is the same as this side length. And this height is the same as right here, right? So this, that means this, like, line is the same as this line. But this line is also the same as this line, as we proved before, right? So all 3 lines are the same. And that's why you take the perpendicular bisector of 2 lines of a triangle. You don't need to take the third one, because if you take the third one, it's just gotta look like this. And it's gotta go through that middle. It's just have the thing. So it's just extraneous work, and then you're gonna waste time. So just don't waste time, basically. So a triangle has vertices 1, 1, 3, 2, and 2, 4. So 1, 1, 3, 2, and 2, 4. Okay, so something that looks like this. So first we're gonna find the point for the centroid, and then we're gonna find the point for the circumradius. Okay, so let's just choose like right here, right? That's our line. So it's like here, and then we use the property of this is 2 to 1, right? So basically, we're just going to have to find that distance to the middle of this point. So what is that middle of that point? Well, the middle of that point is the halfway from 1, 1 to 3, 2, right? So halfway is 3 plus 1 is 4. 4 divided by 2 is 2. So the x-coordinate is 2. And then 1 plus 2 is 3. 3 divided by 2 is like 1.5, right? So halfway between 1, 1 and 3, 2, that coordinate is a 2 and 2, 1.5. So right here, okay? But the other point up here is 2, 4, right? It's given at our question. Now we just need to look for 2/3 of the distance from 2/4 to 1.5, right? So it's 2 to 1. So the 2 to 1 ratio, right? 2 to 1 ratio. That means this entire fraction length is 2/3, and that's 1/3, right? So you keep the ratio, you just add, and then you add together. It's 2/3 plus 1/3 is 1. So you have 1 of that ratio. I mean 1 of that length. You're not have 2 times the length. So I'm thinking of these in ratios. So it's 2/3 to 1/3, right? So you need to find 2/3 because it's 2/3 of length. So instead of doing all the calculations to like find where that point is, basically all you have to do is the method that I found, which is much simpler. We have 2, 4, and we have 1. I mean 2 and 2 and 1.5. Right? Since you see the x-coordinate is gonna be the same, it's basically just gonna be the same place. My drawing is just bad, so basically the x-coordinate is gonna stay the same. So basically the distance between these 2 points, which is 0, the distance between these 2 points is negative 2.5, right? Because 4 minus 2.5 is 5. So you gotta is 1.5. So you gotta remember that. Make sure. Not the distance, but the subtracting. Right? And then you want to get 2/3 of that change. So 2/3 of 0 is 0. So 2 plus 0 is 2. So that's our first point, our x-coordinate. Now 2/3 of 5 over 2.5, we will write that as 5 over 2, right? Right? And we have to take 2/3 of that, so 2/3. Find out, that's negative 5 over 3. Okay? So basically, we have to make a change of negative 5 over 3. Sorry about that if I erased it. That's 2. So negative 5 over 3 from 4. So 4 is same thing as 12 over 3. So negative 5 over 3 from 12 over 3 is the same thing as 7 over 3. Okay? And that's just an easy way to do it. So basically, the circumcenter, I mean, not the centroid, is at 0.27 thirds. Okay? Okay, so we're going to put this point up here so we don't forget. And now we're going to find the point for the circumcenter. Okay, so we have something like this. Somewhat like this. And then we're going to have to find, let's just choose 2 points, right? Let's choose 1, 1 and 3 over 2. So the slope is 2, change in y, change in x, right? So right here, basically. Which is basically going to be a 2 minus 1, which is 1, and then 3 minus 1, which is 2. So y equals 1/2 x. So that's a 1, so you have to add a 1/2. Right? So 3 over 2. So, yeah, so this is the right equation. So we have an equation, right, for these 2 points. So it's 1/2 plus 1/2. So something like this that goes like this. My drawing is just bad. So generally, the line would look something like this. It goes through some kind of point over here, right? So sorry about that. And then we just need to choose another point. So let's choose 2 more other points that are not the same. So not 1, 1 and 3, 2. So let's say 1, 1 and 4, 2 and 2, 4. So 4 minus 1 is 3. 2 minus 1 is 1. So 3 over 1 is just 3. So the slope is 3. So we have 3, so you got minus 2. Okay. So that's 1, 1. It passes through 1, 1. And it passes through 2, 4. Yes. So these are our 2 equations, right? So we have an equation like right here, and we have another one right down here that goes through 1, 1, and 3, 1, 1, and 2, 4. So something like this. So it goes something like this. I just have a bad picture, but that's generally how it's supposed to look like. And then we have to look for the perpendicular bisector, right? Because it has that slope. We just had to look perpendicular. So you didn't have to find the b. I'm sorry about that. We wasted time. But basically, we look for the perpendicular of these slopes. So the perpendicular of 1/2 is opposite and reciprocal. So opposite is -1/2. Reciprocal is -2. So opposite of reciprocal of 3. Opposite is -3. Reciprocal is -1/3. Okay, so we already got that. So we have -2 and -1/3. So let's get rid of this. So y equals -2x, and y equals -1/3 x. Okay. So we chose, so this is the -1/3, right? And this one is the -2. So sorry about that. It kind of just looks like really bad. So then we just need to find that point of intersection. So remember, it has to be a perpendicular bisector. So basically, as for this one is 1, 1, and 3, 2 for the -2, right? So basically, it's gonna go through the midpoint of that. So that's 4. That goes through 2 and 1.5. So you put in that's -4. So you have to add 5.5. And then from here, -1/3 x. It goes through that point go 1, 1, and 2, 4. Right? That's where we got our points. So the midpoint is 1.5. Between those 2 points is 1.5 and 2.5. Okay. So if we plug in 1.5 here, that's -1.5 over 3. That's the same. -1.5 over 3 is just half of it, so that's -1/2. So that's just -0.5. So you had to add a 3. Okay. So this one's +3. Okay. Now you just have to set them equal to each other. So you have -2. So let's kind of put that. Kind of move this over. Okay. So we don't need the picture anymore. Basically, we have to set them equal to each other. So -2 over. Sorry, -2x plus 5.5 equals to -1/3 x plus 3. Plus 2 to the other side, because I want the positive. Usually get the positive. So that is 2 minus 1/3. So that's 6 over 3 minus 1/3 over 3, which is 5 over 3. Okay. And then minus 3 from here, which is 2, which is 5.5 minus 3 is 2.5. Right? So that's just 2 and 1/2. So that's 5 over 2. Okay. So I just want to write them in fractions, so it'll be easier. So this is 5 over 3. So multiply by 3 over 5 from both sides. So multiply 5 over 3 times 3 over 5, that's just 1. So it's 3 over 5. So 5 over here, 5 over here. So x is equal to 3 over 2. Okay. And then plugging it back into one of these equations. So let's say -1/3 times 3 over 2, that's -1/2. -1/2 plus 3 is 2.5, which is just 5 over 2. Right? So these are our 2 coordinates. So this is the circumcenter, 3 over 2 and 5 over 2. Okay. Let's kind of delete all this because we don't need them anymore. And I need more room. So we just need to find the distance between these 2 points. So basically it's just 2 minus 3 over 2, which is basically just going to be that's 4 over 2, so that's just 1/2. And then you square that, plus the distance between here. So 7 over 3 minus 5 over 2. So that is basically going to be a multiply by 2, so that's 14 over 6, right? Top and bottom is over 3, and multiply this by 3, that's 15 over 6. So that's negative 1/6. Okay. Negative 1/6 squared. And then we have to take the square root of this entire thing to get the distance. So this is 1/4. This is 1 over 36. So 1 over 4, let's get common denominators. So the same thing as 9 over 36. So this is 9 over 36 plus 1 over 36, which is equal to 10 over 36. Divide by 2 from the top and bottom, so that gets 5 over 18th. Right? For our point for 14. And now we just gotta take the square root, basically. So square root the top and bottom, square root the entire thing, right? Because we need to square root it, basically. So square root 15 over 8, square root 5 over 18. Okay. So square root 5. Square root 18 is basically just square root 9 times square root 2. So that's just 3 on the bottom. So that's square root 5. 3 times square root 2. We want to get the radical out of the bottom, so just multiply the top and bottom by square root 2. So square root 5 times square root 2 is square root 10. 3, and then 3 times square root 2 times square root 2 is just, square root 2 times square root 2 is just 2, so 2 times the 3 is 6. So this thing is the same thing. So your answer is just written in proper notation. It's just the square root on the top and no square root on the bottom. Because we don't want it like this. We don't want it with the square root at the bottom. We want it a square root on top and then like something on the bottom, if there is one. So the answer is square root 10 over 6. Okay. Pretty simple, but really long. Number 15. Let Sn represent the digit sum. That is the sum of the digits of the decimal number n. For example, 167 equals to 21 because 8 plus 6 plus 7 is equal to 21. If k is a d-digit number, determine the maximum value of s, k plus 1 minus sk, and you take the absolute value of that. So it's going to be a positive number. Okay, so this is just mostly logic. So if you kind of think about it, we want one number to be like, if you add 1 to it, it's got to do a lot of change. So let's just say we have like a number like this, right? Let's say we have 988, right? If you we take the sum of it, right? Because take the sum of this, which is 9 plus 8 plus 8. That's 16. That's 25. Okay, so that will be our sk. If you add 1 to that k, that's 989, plus the sum, it's just 1 more than this one, right? Which is just 26. So it only has a difference of 1, right? So that is not a lot. So let's choose something else. Let's say we have something like 899, right? So that's 9 plus 8 plus 9, so 1826. Now if you add 1 to this, this makes 990. 9 plus 9 is 18. Plus that 0 is 18. You see how there's a much of a difference? Because if we add 1 here, that changes this number to a 0, and then increases the next number. And since this number changes a lot, because that changes from not from an actual number to a 0, then basically we have 1 digit missing. So it becomes like a really big difference. So if you kind of think about it, basically the largest difference would be if you keep adding a 1 and then that 1 carries over to each number. So for it to carry over, that means that it has to be a 9. So think about it. If we have something like 999, if we add 1 to here, that's 1,000. But the original number was 9 plus 9 plus 9, which is 27. Now our next number is 1. You see how that works? Because we have a bunch of zeros. You could do the same thing. Instead of saying 999, we would say 9999. And then that's 18, that's 36, right? Originally. Now if you add 1 to it, we get this, right? So this is just difference. It's just the sum of 1. 36, 1. That's such a big difference, right? So that's basically just a bigger difference. You just kind of think about it intuitively. So if k is a d-digit number, determine the maximum of value of this. So if it's a d-digit number, like if it has 5 digits, then think about it. For k, if it's like 5 digits, then basically you just have 99999. Okay, because that would be the biggest. If you add 1 to it, which gets SK1, that just gets like 0, 0, 0. Sorry about this. 0, 0, 0, 0, 0, 1. So you only have 1, and this one has 9 times 5, which is 45, right? And that has such a big difference. That's a difference of 44. So if they want determine the maximum value, and SK has a digit of D, then basically the difference would just be that difference, which would just be 9, right? Times the number of digits. Because that's basically the amount of 9s we have, and then minus 1. Because SK plus 1 is always going to be a units digit of 1 if you want a maximum. Because we shown the examples with 9999, right? And then we have like add 1 to it is this, right? So this would be if D is equal to 4, right? So this would be 36. Distance is 1. And then C, 35. Difference of 36 minus 1 is 35. Plug in 4 into here. That's 36. Right here is this number. And then minus 1, which is this number. So this is the equation. So this is your answer. 9D minus 1. It's basically just that simple. It just takes a little bit of logic. So I did it fast like this because I already did the question. But it might take a good minute or 2 or 3 to understand how this works. Okay. Number 16. A has a coordinate of -4, -3, and T, a trisection point of AB, has coordinate of 0, 5. Determine the coordinates of B. Okay. Unit plane. -4, -3, so somewhere here. Okay. Usually when I have a graph, I kind of just, if it has a coordinate plane, I usually just draw it, but not precisely, just get a rough idea how it looks. And AB. We have a trisection point at 0, 5. So we have something like this, okay? So since it has a trisection point, right? We don't know what that trisection point is because there's like kind of several points, right? So let me scale this up actually right. Let's do something like right here. Right here, and then right here, and then draw a bunch of points, right? So either this is A, right? This trisection point of A, B, right? And this is T, right? And this is one of the trisection points. And there might be, and this is the second trisection point. That means this is 1/3 of the length. This is 1/3 plus another 1/3 plus 1/3, right? So that is one answer. Another answer would be like if this is the trisection point, the second trisection point. So we have a line like this, right? And this is A, and this is B, but this is 0, 5. So this is 2/3 of the difference instead of 1/3 the difference. So there's two possible answers. Okay. So we need to look for B. So let's just think about it when it's 1/3. Okay. So -4, 5, 0, 5. Then you have to look for that. This is 1/3 of the distance. Okay. So an easy way to think about it is just changing y or changing x. So you kind of just draw this triangle. So all you have to do is -4 to 0 is sorry about that. So it's distance. Okay, I'm not the best drawer, but the distance from -4 to 0 is just 4. And from -3 up to 5, that's a distance of 8. So that's 1/3, and you will go 2/3, right? So you have to do 2 times as much. So instead of adding 4 to the right, you have to add 8. And instead of adding 8 up, you have to add 16. Right? Because it's 2 times as much. So you add 8 to the our coordinate was 0, 5, right? So you have to add 8 to the 5, to the 0, because that's the x coordinate, and add 16 to the 5, which is 21. Okay? So that's our first answer, 821. Okay, I'll write it down here so we don't forget. So that's our first answer. Our next answer would be right here, right here. Right, so something like this. So a point right here, then B is right here, so A is B. So this is our point T at 0, 5 is already 2/3 of the distance, right? So this is the other trisection point. It's below it, not above it, okay? So Basically, it's super simple. We just need to find equal distance. So all we have to do is basically, if you think about it, we have we started at negative 4, negative 3, right? And then we have basically 0, 5. And then we have the coordinates of b, which we don't know what it is. And this is usually how I format it. So this, and what I write on the side is that basically this has to be 2/3, right? So this is 2/3, and this is 1/3. And this is how I format it. And then in the middle between these numbers, I leave spaces, and then I do the math. So from negative 4 to 0, you have to add 4. From negative 3 to 5, you have to add 8. And that's 2/3 to 2 to 4. So 1/3 would just do half of that, right? So that has to be plus 2. So 2 plus 8, that's 2/3 of the distance. So 1/3 would just be half of that. So that's plus 4. So this side length is just plus 2 from the 0, which is going to be equal to 2. And then you just have plus 4 from the 5, which is equal to 9. It's just how I think about it. Instead of finding slope and everything and distance, this is a really simple way to think about it. So our other answer is 2, 9. So our answers is, oops, this and these two. So our answer is 8, 21 and 2, 9. You need both of these answers. Because on the question, when they said a trisection point, number 16, the T is a trisection point, they didn't specify which trisection point. Is it the 1/3 part or is that the 2/3 part? So you have to put in both because there's two possible answers. Question 17. By traveling at a constant speed, a certain wombat can complete a given journey at time t1. However, if she was to instantaneously increase her speed at 10% halfway into her journey and keep the speed for the remaining of the trip, her total time would be t2. Compute t1 minus t2 in parentheses divided by t1. Okay, so first we need to find the relationship between t1 and t2. So basically, she said that by traveling at a constant speed, so her speed is constant, a certain wombat can complete a journey in time t1. So let's say her speed is s, right? So her speed is s, then basically her distance travel is s times t1, right? Is equal to x, right? Because if she was traveling like 50 meters per second, right? And it takes her like 20 seconds, then 50 meters per second times 20 seconds is like 1,000 meters, right? So that's how you calculate it. So that's true. Okay. Now it said for the second sentence, however, if she were to instantaneously increase her speed 10% halfway. So for the first half, she was traveling at original speed. So it's s times t1 divided by 2, right? Because it's halfway. So if you divide this by 2, that means this has to be divided by 2. So you had to travel half the distance. Because you can't change the speed. You're not changing the speed. You're changing the time. So you change the time to half. That means you travel half the distance. Plus, and then for the other half, you're traveling at 10%. You increase your speed by 10%. So 10% plus the original speed is just 1.1. And we'll write it as a fraction. 1.1 is the same thing as 11 over 10. Right? 11/10 of the speed. And we need to find the time. So it said that it keeps that speed for the remaining of the trip. Her total time would be t2. Her total time would be the time it takes for the 10% speed, increased 10% speed, and the original speed. So if you take out the speed for the original speed, that means all the time you have left is basically that 10% speed, right? So basically, it's just t2, which is your total time, minus. Let's draw this a little. Let's make this a little smaller. t2 minus your speed for your original, t1 divided by 2. Then basically, this thing would just give the speed for the 11 for the 10% basically. So this will give us the distance halfway when you're going the original speed, and this will give us the distance for when you're traveling at the 10% at 10% increased speed. So basically, you're traveling the same distance again, which is x. So you see what we're gonna do? We just gotta substitute x in here. So we have s t1 s times t1 over 2 plus 11 over 10 s times t2 minus t1 divided by 2 is equal to s times t. I'm not going to substitute it in because I don't have the room for it. But basically, if you kind of just think about it, you're just going to put this here. This is the same thing. This is equal to x and this is equal to x. So you just plug that in. Just a simple substitution. And then you see that everything has s. So you kind of just could cancel out the the s. So you could cancel out the s. So divide s from both sides. Right? And you're left with this. And then you have t1. And this is a 1/2 of t1. So just 1 of t1 minus 1/2 of t1 is just 1/2 of t1. So you have 11, the side, which is, you didn't change at all. 11 over 10 times t2 minus t1 divided by 2 is equal to 1/2 of t1, right? Okay, we don't need this because we're basically just simplifying now. Now, we just need to distribute this out, so that's 11 over 10 t2. Sorry, I'll make it look like a subscript. Minus 11 over 20, because 11 over 10 divided times 1/2 is just 11 over 20. t1 is equal to 1/2 t1. Okay, so you just add 11 over 20 to both sides. So this is also the same thing as 10 over 20. So 10 over 20 plus 11 over 20 is 21 over 20, right? So this would be equal to 21 over 20 t1. And then you basically multiply by the reciprocal, so 10 over 11 times 10 over 11, right? So this cancel out, and we just get t2 left. So t2 is equal to, this 10 cancel out this to a 2. So this just be 21 over 22, right? So 21 over 22 of t1. And that's what we have. This is the relationship between t1 and t2. Now we want to find, for number 17, t1 minus t2. So t1, t1 minus t2. T2 is this, 21 over 22 over t1, right? So we get the same variable, t1 and t1. And then we have to divide by t1. So just divide by t1, right? Now you can just do the calculation for here. So basically, it's just t1. This is 1 t1, so it's just the same thing as 22 over 22. So 22 over 22 minus 21 over 22 is just equal to 1 over 22 t1 divided by t1, right? So you can just cancel out the t1, and all you have left is just the 1 over 22. So that's your answer for number 17, 1 over 22. So the first thing you have to do is just basically find that relationship, and then you just plug it in. Basically that simple. It just takes a while to get the relationship. Okay. Number 18. Determine the area of the closed region bound by graphs x times y plus 3x minus 2y minus 6 is equal to 0 and x plus y is equal to 12. Well, let's work with the first graph, which is x times y plus 3x minus 2y minus 6 is equal to 0. Okay, we're just going to factor by grouping. So factor x, y plus 3x. So factor out the x out, so that's just y plus 3. Okay, now we're going to do the same thing for negative 2y minus 6. So divide by, factor out the negative 2, so this y and this is plus 3. See, we have same groups, y plus 3 and y plus 3. That's equal to 0. Okay, so this is the same thing as x minus 2 times y plus 3 equals 0. When you have these type of graphs, you have different variables, x and y. What it kind of looks like is it looks like two lines. So this one's at x is minus 2, so it's going to be x is equal to 2, right? Because if x is equal to 2, then this entire thing is going to be 0 regardless of y plus 3 is. And if y is equal to negative 3, right, then it's going to be 0 regardless. So you have these two lines. So this equation is just two lines together. Okay, so it looks like this. And now we have the last line, which is x plus y is equal to 12. So we have something like this, right? And then we just need to determine the area of the closed region. So we have to find this area. So remember this. This is at x is equal to 2, and this is at y is equal to -3. Okay. So basically, we just gotta find out what the height and the length is now. So they gave us that the equation is x plus y is equal to 12, right? So if x is equal to 2, right, at this line, then what's the height? Well, the height is, if x is equal to 2, then the height y is equal to at 10, right? So the height here is at 10, right? It's at 210. And if our y right here at this line is -3, then what is our x, right? So basically, our x at this point, because you're looking at this line, right? Because if y is equal to -3, then x, plug it in, that's just 15, right? So 15, x plus y equals 12, so 15 minus 3 is 12. So we start at 2 and end at 15, so that's a difference of 13. And we start at 10 and end at -3, so that's also a difference of 13. Right? Because 10 minus -3 is just +3, so that's 13. So that's a triangle, a right triangle. So basically, it's just 13 times 13 divided by 2. So basically, it's just base times height divided by 2. You know, the area of a triangle formula. So 13 times 13 is 169 divided by 2. And you can just leave it like this. So your answer is 169 over 2. Basically, just that simple. Okay. Number 19. Determine the distance between the point 2, 3, 4 and the graph x is equal to 0 and y is equal to 2. Okay, let's kind of draw a graph. So something like this. This is the x-axis, this is the y-axis, and this is the axis. So we have a point at 2, 3, and 4. So yeah, somewhere around here, right? So 2, 3, 4. So let's kind of draw this out with like dotted lines. So this distance at 2, this up here is 3, and this distance is 4. Okay. Let's kind of draw it somewhere else. So right here, 4. Okay. And he says the graph at x is equal to 0. So x is equal to 0. And z is equal to 2. So looks something like this, right? Because z is equal to 2 here, and x is equal to 0. So it doesn't move this way at all, or this way. It just stays at this line. And it goes here, and it could be any y. So it goes here. Okay. So we're going to think about how this looks. Because they said that z is equal to 2, so this distance right here is 2, right? This distance right here is 2. And x is equal to 0, so this is at 0. So what's the distance between this line to this point from here? Well, basically, it's at x is equal to 0, right? And the point is at 2 distance away from x. So at the x-coordinate, it has a difference of 2. Right? And then at the height doesn't matter because basically the line is going to be at any height. So now we just need to look for the distance between the z. Our z is for the point is at 4, but the z for the line is 2. So 4 minus 2 is 2. Right? So if we kind of look about it, this thing it's kind of hard to see, but basically it's going to look like this. And this is going to make a light triangle. So that's basically how it's supposed to look. So let's kind of like do this without the numbers and then see how this looks. Okay, so let's take this out. So you have a line like this. Then basically just change color so it looks a little better. So it looks something like this. And then you're going to make a line that's perpendicular to this line. So it makes a right angle right here. And then you make a right triangle, right? So the difference between this line is the x-coordinate. So the difference between the x-coordinate, this is at 0, this is at 2. So this is going to be a difference of 2, right? Now this is going to be the z, right? So this one is at 2, and this one entire thing is 4. So this one's just 2 more. So if we want to find the length between those two, it's just a right triangle, right? So it's 2 and 2. So it's just 2 squared plus 2 squared, and then square rooted, right? So that's 4 plus 4, that's 8. Square root 8 is just 2 square root 2. So that's your answer, 2 square root 2. So you just basically draw a picture. Basically just that simple. Okay. Number 20. Let x, y, and z be positive integers that satisfy equation x plus 2y minus 2z is equal to 10, and 3x plus 3y plus 6z is equal to 90. Determine the maximum value of product x, y, z. Okay, so we have x plus 2y minus 2z is equal to 10, and 3x plus 3y plus 6z is equal to 90. I see that this is negative and this is positive, so I want to cancel it out. So multiply this equation by 3. So that's 3x plus this 3x is 6x. 2y times 3 is 6y plus this 3y is this is a 3. Sorry about that. And that's 6 plus 3. That's 9 plus 9y, and that makes negative 6z. This is 6z, so that's 0. And that's 3 times 10 is 30 plus the 90 is 120. Okay. So they're all multiples of 3, so divide by 3. This is 2x, this is 3y, and this is 40. So we have 2x plus 3y is equal to 40. Okay. So 2x plus 3y is equal to 40. So what numbers can we use? So usually when I do this, I just start choosing small numbers and go up. So x is equal to 0. Is 40 divisible by 3? Does not work. Okay. So if x is equal to 1, that's 2. So 40 minus 2 is 38. Is 38 divided by 3? Does not work. Okay. So if x is equal to 2, that's 4. 40 minus 4 is 36. Okay, 36 is divisible by 3. So the first number is 2. And the next number, that's 36. 36 divided by 3 is 12. Sorry about that. So basically, we have 2 and 12. The easy pattern about how these work is that whatever this number is, choose the other number, and that's what it's going to be scaled by. So it's going to be scaling by 3. So you're going to add 3 to 2, that's 5. So if it's 5, that's 10. 40 minus 10 is 30. 30 divided by 3 is 10. You see how it's scaling? If this one is adding a 3, this one is minusing a 2. Right? So you add another 3 again, that's 8. Minus 2, that's 8. If you add a another 3, that's 11. Add minus another 2, that's 6. Add another 3, right? So that's 14. Minus another 2, that's 4. Add another 3, that's 17. And minus another 2 is 2. Right? So you can always make sure, you just plug it in to make sure they're correct. So that's 34, that's 6, that's 40. Yeah. So that works. So these are only combinations. Well, you can't have 20 like 0 because 0 is not a positive integer, which they said x, y, and z has to be positive integers. So y is equals 0 and 0 is not a positive, so this doesn't work. So these are all the only combinations. Okay, so it said z is a positive integer also, so we need to check if z is here because these are only x and y's. So basically, you can just plug in back into the equation to check if you're right. So all you have to do is, we have 2x plus 3y is equal to 40. So why won't we just find something we could substitute and then cancel out? So I notice on the bottom, which says 3x plus 3y plus 6z is equal to 90, right? And I know that 2x plus 3y is equal to 40. That means if you substitute that in, if you take out like an x, right? So 3x plus 3y plus 6z is equal to 90, right? If you take out an x here, so this becomes x plus 2x, it's the same thing. But now we have the 2x plus 3y is equal to 40. So x plus 6z plus 40 is equal to 90, right? So I'm just splitting up by parts so we don't have to do a bunch of math. So this will be equal to x plus 6z is plus 40 is equal to 90. So 90 minus that 40 is 50. Okay. So if we put x is equal to 2 here, that's 48 divisible. So this works. This will give us a 8. So z is equal to 8 for this one. Sorry about that. So z is 8. If x is equal to 5, that's 45. Divide by 6. 45 is not divisible by 6, so this is not going to be an integer, so this doesn't work. We don't have to try this combination. If x is equal to 8, that's 50, that's 42. 42 is divisible by 6, 7. So that works. So if x is equal to 11, so 50 minus 11, that's 39. 39 is not divisible by 6, so this doesn't work. Put 14 here, so 50 minus 14 is 36. 36 is divisible by 6, which is 6. Okay, I kind of see a pattern here, so it works, does not work, works, does not work, works, so I'm guessing this doesn't work. We'll go also check. So put 17 here, so 50 minus 17 is 33. 33 is not divisible by 6, so it doesn't work. Right? So we only had these three combinations. The x, the y, and the z, right? So x, y, z, x, y, z. So there are only these three. So basically, you just need to check these three combinations and which one has the biggest, right? So you can just use your calculator. So we have 8 times 2 times 12. That is 192 for this one. Now 7 times 8 times 8. That's 488. 448. Sorry about that. And we have 6 times 14 times 4, which is equal to 336. So they said determine the maximum value. This is the maximum value, basically just that simple. So the answer for number 20 is 448. And that basically completes everything for the CCML Algebra 2 Contest 1 2017-2018. Thanks for watching, and now see you at the next math record.